Hi, I will present today a brief of ongoing research project on overheating and indoor air quality in school, particularly new build, and the potential solution. My name is Sarah, and currently a PhD researcher at the University of Nottingham. In this presentation today, we'll highlight it and go through the school environmental performance in the terms of the school building and indoor air quality, then go through UK climate projection, objective of the field study, methodology, and look through the case study, then the main finding result, and we'll finish with the main finding and conclusion and future aspect. UK housed 10 million students who spend almost 30% of their life in school and 70% of their time inside the classroom during school time. Achieving an adequate indoor air quality while accommodating a specific period and different age level that are considered to be a very high occupant density can be a particular challenging, as these high occupancy classroom density can cause high internal gas, high CO2 level, and high concentration of several dust such as PM2.5 and PM10. Why is a school environment performance important? I will explain in terms of the building performance and indoor air quality. In terms of the building performance focus on reducing the energy performance. This is in the line with the current policy objective related to the energy efficiency and the climate change mitigation. Also, the UK was the first country adopted, and it reduced a long-term binding framework to reduce the climate change crisis, which aiming to improve the building performance through a highly insulated and airtight building envelope. However, can low carbon school provide a comfortable teaching environment in the future? Or will future low carbon school in the UK adopted for the future climate? Or can we minimize the overheating and indoor air quality? UK climate projection reports that by the mid of this century, hot summer and high temperature could become common in the UK. Let's remind ourselves that the heat waves in 2006 brings the school to close because of the temperature recorded more than 36 degrees in many of the classrooms, as hotter classrooms harm the children's academic performance. At this time of the year, the assessment took place during summer. So this will lead us to say, why is the school environmental performance important in terms of indoor environmental quality? Because improves occupants and health and well-being and definitely affect the productivity. Just remind ourselves of the parameters of indoor environmental quality, such as thermal comfort, air quality, visual comfort, and acoustic comfort. Also, there are more parameters of indoor environmental quality in schools, such as CO2, temperature, humidity, VOCs, PM2.5. As higher CO2 and higher temperature in the classroom can cause a significant impact on the student performance and the health, as the PM2.5 and PM10 leads to the heart-lung disease and asthma between the students. Project by Professor Peter at the University of Salford in Manchester examined 3 types of the physical specific of the classroom, which called a clever classroom, which examined the stimulation, individualization, such as flexibility or ownership, and naturalness, such as air quality, temperature, and light, in 27 schools and in 153 classrooms. Found out that naturalness such as temperature, light, air quality accounted for half of the labeling impact on the children's academic performance. Objective and the papers of the field measurement in school study observed the indoor performance of the new build and low carbon classroom in primary schools in terms of the indoor environmental performance and compared the actual data and the result collected against the guideline and regulation for indoor environmental quality in school, such as Building 14101, SIPSI, and the Passive House for Efficient Education use in school. And situ method adopted for the field measurement study for 10 working days in summer in 2 case studies, one in Nottingham and one in Mansfield in UK. This shows the case study 1 and case study 2 and the defined classroom zone with the school building plan, which indicating the location and distribution of the measurement device and the equipment in the case study school zone. Also, the result highlight the second level analysis, which show the occupancy, the window and the door opening schedule code, and also plotted the weather data in terms of the overheating and indoor air quality. The figure shows continuous measurement of the field study at one of the classroom at case study 1, the air in the globe temperature recorded was more than 22 degrees, which is the temperature benchmark for the low carbon school, and reached more than 25 degrees during the school hour. Also, this is a result of a reception classroom in case study 2 show the temperature recorded more than 27 degrees compared with the temperature benchmark. A bigger picture of the result highlighted the recorded temperature, which reached more than 27 compared with the outdoor weather and the temperature benchmark. The results show the mean and maximum, the average during a school day for every school hour from 8 until 3, which show in depth a higher temperature recorded more than 26 compared with the temperature benchmark. If we took 2 days and show how much percentage of the temperature recorded between 23 and 25 degree is more than 46%, and above 25 degree more than 64% during the occupied hours. Just pick a picture of the percentage of the air and the globe temperature recorded during the occupied hours at the classroom. Regarding the indoor air quality, the figures show the continuous monitored all the parameters of the field study and the CO2 level, which show the higher than the CO2 benchmark, which recommended by the school guidelines. Also, the indoor air quality and CO2 level for the 2 classroom in case study 2. This showed the minimum and maximum, the average of the CO2 level for every school hour and the percentage of the typical school day at the classroom between 1,000 and 2,000 parts per million, recorded more than 62 and 64%. Main findings of the field study measurement. The results show that the monitored classrooms are considered to be at the risk of overheating during summer periods. These measures should be taken seriously, as the UK is expected to experience further rise in the temperature every year and at least 7-degree increase by the end of the century. The internal air temperature and the global temperature fell below the acceptable standard regulation for comfortable temperature, and the space were overheated more than 60% during the occupied time. The field measurement will fall within the current UK recommendation standard to ensure the adequate indoor quality in the classroom. The design of the single corridor classroom or the cluster learning space will prevent the cross-ventilation. So the result in this paper indicate that the next step, therefore, it should be discussed how future design of the school can adapt to the changing the UK climate in the future. So the potential solution will be presented in our future work. Thank you for listening.